Hello and welcome to your first chemistry video where we're just going to go over the basics of chemistry and science today. So what is chemistry? Chemistry is the study of matter, and we try to study matter by looking at the smallest parts of matter. Let me just get my laser pointer out here. All right. Now we look at atoms when we study chemistry. Atoms are just small particles that are the building blocks of everything. Everything in the world is made out of atoms if it's matter. And molecules are just atoms bound together in specific shapes. So let's look at a few molecules here. Here we have the molecule water, H2O, made up of the atoms oxygen and hydrogen bound together. Here we have the molecule hydrogen peroxide, which, if you notice, is also made up of oxygen and hydrogen, but you have different amount of atoms bonded in a different way. And third, we have a bigger molecule that's actually found in your bodies. However, in this class, we're not going to look at anything nearly this complex. Now, for molecules, it doesn't matter just what's in the molecule, but it matters how these atoms are arranged. And the best example of this is if you compare graphene or pencil lead to diamond. Now, both of these molecules are made of this very same atom, carbon. That's all they are. They're carbon. However, they have vastly different properties because they are bound in different ways. Soft graphene versus hard diamond, the main difference is an extra covalent bond. Now, later on in the course, we'll talk about what covalent bonds are, but for now, it's important to know that how atoms are arranged in molecules affects their properties. Now, chemistry is a science class, so we have to get some science lingo down. Now, science is an empirical field. That is, we make our assertions through observation and experiments. And we come up with our theories and our hypotheses by doing experiments on the physical world. And there's really two types of data we can have. We can have qualitative data, that is, we describe something, or quantitative data, we put numbers to something. So the good example of this is if we're trying to describe fire. Now, if I would be qualitative about it, I would say, fire is hot, it has a red or white flame, it starts when I use a match, so on and so forth. However, if I want to be quantitative about something, I would say fire burns at 4,000 degrees, fire uses X amount of fuel per hour, things like that. Generally, you want to be more quantitative than qualitative if you can. And a good example of this in chemistry is from a famous chemist called Lavoisier, and he's the one who really came up with oxygen. Now, back 300 years ago, people thought objects burn because they contained this substance called phlogiston. Now, Lavoisier did a bunch of experiments and he showed, no, it's not that something in the substance burns, but what happens is that oxygen burns, and that's why we get fire. And he helped to discover the element oxygen. Now, we have to get some different vocab down if we want to be scientists. And the first is just hypothesis. And it's just kind of an interpretation or explanation of different observations. And any hypothesis must be falsifiable. So I'm going to give you two examples here, and this will be a good intro to how we do problems in these videos. I will give you a question, then I want you to pause it, think about the answer, try not to look up the answer, and then when you have an answer, press play. This will be the best way for you to learn through these videos. So ask yourself, is this a good or bad hypothesis? My dog sleeps on the bed when I'm not at home. So pause it now. All right. Now, this is a good hypothesis because we can test that. I can put up a camera in my bedroom. I can look for dog hair on my bed. I can see if the bed sheets are messed up and come to a conclusion that, yes, either my dog sleeps on my bed or my dog does not sleep on my bed. So, second hypothesis. Invisible aliens are responsible for waking you up before your alarm goes off in the morning. Take a second and ask yourself, is this a good or bad hypothesis? And the answer is, this is a bad hypothesis. There's no way I can falsify this because I can't measure it. How are you going to disagree that invisible aliens wake me up? You can't see them. I can't see them, so I may or may not be right. So that is a bad hypothesis. And these hypotheses are tested by doing experiments. An experiment is just highly controlled procedure designed to generate data, either qualitative or quantitative data that either confirms or denies a hypothesis. Now, after so many observations, we can come to what's called a law. And a law is just a brief statement that summarizes past observation and predicts future ones, or they describe how nature behaves. Not why it behaves, but how it behaves. One law is the law of conservation of mass that says mass cannot be created or destroyed. And this is just a law. Every time we do an experiment, we know we cannot create or destroy matter. We don't know why that is because of that law. We just know that is a fact. And laws, like all of science, are subject to different experimentations and can be proven wrong. Now, we have scientific laws. Now let's look at scientific theories. And that is, if we have a hypothesis and we do many tests on that, we can start to create a model to explain why nature it is the way it is. That is, a theory explains the why of things. And some examples of theories are atomic theories. Everything is made out of atoms. Germ theory. There are germs. The theory of evolution. Life evolves. Heliocentric theory. The sun is the center of our universe. Gravitational theory. Things attract. There's gravity. Now, theories are really as close as we can ever get in science to saying why something is. But like all science, they are subject to be changed from experiments. However, the phrase that is commonplace, especially when it comes to evolution, is, why would I believe it? That's just a theory. And so when people say that, they're confusing the word theory. When people say it's just a theory, they're thinking of the English word for theory, which is closer to hypothesis. In science, if something is a theory, it has been gone through many different experiments, and it's just a combination of these experiments to explain why something is the way it is. And when you do science, you have to be very rigorous if you want to get good results. And we have something called the scientific approach for that, where you have observations and you will either come up with a hypothesis or a law for those observations. Laws are extremely rare, so what's going to happen 99.9% of the time is with an observation, you're going to make a hypothesis. Then with the hypothesis, you have to do tests or experiments to either confirm or deny your hypothesis. And if you deny your hypothesis, you usually try to revise your hypothesis. So this is an iterative or repeating process. After enough tests, you can start to put together a theory as to why something is the way it is. However, with a theory, you still need to do this iterative process of doing experiments to either confirm or revise your theory. And note, science is a team game. Although there might be a perception that scientists work alone, scientists never, ever work alone. Now, I'm going to end this video with a question. Again, please pause it before you hear my answer. But which statement best explains the difference between a law and a theory? Is it A, a law is truth, a theory is mere speculation? B, a law summarizes a series of related observations, a theory gives the underlying reason for them? Or C, a theory describes what nature does, a law describes why nature does it? Take a second to think about that. All right, so the correct answer is B. A law summarizes a series of related observations, so it says what nature does, while theory says why nature does it. So if you flipped around the what and the why and C, that would be correct. A is never correct. All right, thanks for watching this first video, and good luck with the rest of the videos. See you then.